Hey there, hello, hi everyone, welcome back to the channel. So continuing in this series where we are solving problems related to trees. In this video lecture, we'll be solving this problem, that is a binary binary tree Inorder Traversal. So in this mastering the technical interview sheet, we have this binary tree Inorder Traversal, which is the second problem of this series. We will be solving this problem today. Although we have already solved this problem a lot of times, but still for the sake of revision, whatever you say, we will have to solve this problem in order to complete this sheet. So let's just see how we will be solving this problem. But first let's understand what is a binary tree. You know what is a binary tree? A binary tree is a tree where every child has at most 2 child nodes. Okay, that is a binary tree. And this binary tree can be traversed in multiple ways, and this in order traversal is one of the ways to traverse the binary tree. So let's see how we will be looking at it. So let's take this example 1 2 3 and it's write its in order traversal. So 1 right child, so we have 1 and then we have 2 and then we have 3, right? And we are supposed to write its in order traversal. So what is the meaning of in order? In order means first visit left subtree, then visit root, finally visit the right subtree. Okay, so this is the order in which we visit these child nodes. Left and then root and then the right. So here in this video lecture we will be solving this problem and we will be writing this traversal. So we have left subtree, that how we are going to visit. So does this have, so we'll start from the root node. So root node, so let's check for the left child. No, it doesn't have a left child. Then move to the root node. Yes, we have a root, print it. Then move to the right child here. So does this right child have a left child? Because this is itself a tree. अपने आप में ये एक ट्री है, तो ये भी उसी ऑर्डर को फॉलो करेगा. लिसन, एवरी नोड इज गोइंग टू फॉलो दिस ऑर्डर, एवरी नोड. सो वी वर एट 1, इसने देखा लेफ्ट में कुछ है नहीं है, फिर इसने खुद को प्रिंट किया, फिर इसने देखा राइट में कुछ है और कंट्रोल को भेज दिया राइट में. कंट्रोल आ गया राइट में यहाँ पे, ये भी वही ऑर्डर शुरू कर देगा. लेफ्ट देखेगा 3 है तो 3 को प्रिंट कर देगा, फिर खुद को प्रिंट करेगा, फिर राइट में देखेगा राइट में कुछ नहीं है, एंड देन the traversal ends. So 1 3 2 is the in order traversal for this tree. Let's take one more example, क्योंकि 2 एग्जाम्पल लेंगे तो ज़्यादा बेटर में समझ आएगा. 1 2 3 4 5 6. Let's take this example, a better example. So we'll start with 1. So we print 1. No, print नहीं करना. 1 पे आए, ऑर्डर क्या देखो, लेफ्ट देन रूट एंड देन राइट. तो मूव टू लेफ्ट 3, सेम ऑर्डर, मूव टू लेफ्ट 4 से वापस आए 3 पे, 3 को प्रिंट किया. 3 से जाएंगे राइट पे 5 का लेफ्ट राइट नहीं है तो 5 को जो करते हो, क्यों, क्योंकि इसका लेफ्ट है नहीं है तो 5 प्रिंट होगा. फिर 5 का राइट है नहीं है तो विल मूव बैक. 3 से अब वापस मूव करेंगे 1 पे. तो ये कवर हो गया लेफ्ट सब ट्री, एंड देन विल प्रिंट 1 एंड देन विल मूव टू द राइट वन. Here 2 के लिए again same order. Do we have something on left? Yes, we have 6. Then we will move to the root. We have 2 and then we will move to the right. 4 3 5 1 6 2. 4 3 5 1. 4 3 5 1 6 2. देखा 4 3 5 1 6 2. नॉर्मली अगर आप देखें तो इट्स वेरी अनप्रिडिक्टेबल है ना. तो 4-5 एग्जाम्पल लो, आपको एक अच्छा पैटर्न इसमें दिखेगा. So let us see how we can solve this problem. A very easy problem. We do not have to do much in this. All we have to do is just to repeat a single structure for every single node. That's all. And that thing can be done by the recursion. So let's write a recursive function. Let's call it in order traversal. And here we will have this tree node, root, fine. and here we will see if root null, then we will simply return. Otherwise, call the same function in order traversal for the left child. अच्छा ये CPP में ओरिएंटेड है थोड़ा, बट ठीक है. And then call the same function for okay. So that's how you are supposed to do it. Cool. So in this fashion, this answer array is prepared, and we are supposed to find the. We will be implementing this solution here in this lead code platform. So let's see. ठीक है, तो बनाते हैं एक आंसर अरे बनाते हैं. एंड इन दिस आंसर अरे विल बी. अच्छा, सबसे पहले तो अपन देख लेते हैं कि रूट अगर नल है तो रिटर्न आंसर राइट फ्रॉम हियर. देन वी विल कॉल दिस फंक्शन, लेट्स कॉल इट इन order. It takes the root node and then it takes the answer, return this answer. No, return nothing, just return. Otherwise बोले return in order root left answer dot pushback. So let's call this in order, which is here. Then from here you will return this answer. Okay, आंसर नहीं पास करे. ठीक है. So that's all for this video. I hope you liked it, and let's just understand the time and space complexity for this. Space complexity is constant, we are not using any extra space. Big of 1, but नहीं, but कॉल स्टैक तो ऑब्वियसली लग रहा है, तो कॉल स्टैक की स्पेस कितनी होगी जो नॉन ऑक्सिलरी स्पेस है. ऑक्सिलरी स्पेस इज कांस्टेंट, बट द कॉल स्टैक वुड बी n. क्यों? क्योंकि लुक एट दिस ट्री. Up to n. So if you look at this tree, what we have is you can see that in the stack we can have at most n nodes, and that's all. So here in this video we will so let's just discuss the space time complexity. Time complexity क्या होगी? Time complexity would be big of n, because we are at most visiting every single node. ठीक है, we are visiting every single node, that's all what we are doing here. So big of n would be the time complexity, and that is all. I hope we will start covering these solutions in other languages है ना. C++ में तो पहले भी कर चुके हैं हम बहुत बार. So I think we should shift to Python or Java. From the next upcoming videos or playlists, we'll be solving these problems in Python. यहाँ है Python का option. ठीक है. Okay, so that's all for this video. I hope you learned something out of it, and you will apply the learnings for the rest of the similar problems. So I recommend you, after you watch this video, if you come across this video, I recommend you to solve problems which are pre-order traversal and post-order traversals. After you learn this DFS from this Inorder Traversal from this video, that will enhance your learning, and hope to see you all in the next video. Till then, take care. Bye bye, ladies and gentlemen.